Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is maximum number of ones row. Okay, so let's take a snap of this statement. So basically, this type of array are given to us the 2D Boolean array. Boolean array means this array contains only zeros and ones, where each row is in sorted order. Each row is in sorted order. This type of sorting is there. Okay, this type of sorting is there. Okay, now find the row number which will contains the maximum number of ones. So in this question, we need to return a row number, a particular row number that will contains the maximum number of ones. Basically, in the zeroth row, we have two number of ones. In the first row, we have zero number of ones. Zero number of ones. In the second row, we have four number of ones, and in the third row, we have three number of ones. So basically, in the second row, we have four number of ones, and this is the maximum number of ones that are present in particular row. Okay, so we need to return that row number. Okay, so how to approach this question? If you are using the brute force method, what is the brute force method here? If you are using the two for loops here, nested for loops here, then you can get easily that count of ones and that row number also, but it will cost the time complexity as that is O of n into m. So we are traverse on this loop into n and m times. We are traversing in each point, and that time complexity is O of n into m. But this array is in sorted order, so we can optimize this solution by using binary search. So our optimized solution is work into O of log n into log m. So this is our optimized solution, and this is the time complexity for the optimized solution. So what is the approach? What is the approach to solve this question into O of n into log m? So first, for finding the count of ones in each row, we need to initialize the one variable that contains let's say first index. It contains the first index of 1 here. That in each row, it contains the first index of 1. So the first index of 1 in this row, we got 1 at the third index. So that this is the first index, or the 1 that from the third index 1 is started, because this is in sorted order. 1 is started from this index. Now we need to calculate count, how much number of ones are present in this. The boundary for this ones is this. The boundary for the boundary of this row is at this point. Okay, at this point. So we can say that it is the fifth point. Okay, fifth point. The boundary is present at the fifth point. So if this is the matrix, we are saying that this is the matrix, and we are writing the matrix dot size that gives us a 4, that is row number. Okay, and if we are writing the matrix of 0 dot size, then it will give us 5 as a column numbers. Okay, so we can get easily count. So matrix of 0 dot size, that means 5 minus first index of 1, that is 3. So it will give 2, and that is our count of 1. Okay, count of ones that are present in that particular row. Now let's talk for the first row. In the first row, we got our first index at, there is one is not present in the first row. So we can say that we got the first index of 1 at the fifth point. Why fifth point? Because we have to calculate the count, and we are subtracting the value from the matrix column size, that means 5. And if we are initializing, when all the zeros, we are initializing our first index of 1, 5, then we are subtracting the 5 minus 5, and that will give us 0. Okay, now for the next second row. In this row, the first index of 1 is present at the first index of column, and the count is 5 minus first index of 1, that is 1, is equal to 4. So we got the count of ones in this particular row. So this is the approach to solve this question. If you got any idea how to code, how to convert this approach into code, so do the code by yourself. Pause the video here and do the code by yourself. From this point, I am starting with the solution video and the code video. Okay, now for okay, let's try the code, some code first. After that, we are try run that code. Now we are starting with the row number. Row number. Row is at 0. Row is less than matrix dot size and row plus plus. Okay. Now we are at this point. This point. Now we are passing the row number to the binary search. We need to we have a faith in a binary search that will gives us the count of ones in the particular row. So we are calling the binary search from here. Binary search from here, and we are passing the matrix as well as row also. Okay, and it will give us the count of ones in that row. Okay, in that row. So it will gives us the count of ones in that particular row. Okay, in that particular row. So we are passing the matrix and the row number to the binary search function. Now if we have faith in this function, and it will gives us that count of ones. Now at this point we are initializing our what we say that if we are initializing the count of 1 here as a 0, and we want a row number as well, row number, and we are initializing it as a 0. Okay, is this number gives error to us or not? Is this line row? Okay, method dot size int. Let's stop this. Okay. Now we have faith in this function, in the binary search function, that will gives us the value of count of the count of ones in that particular row. So now we are comparing that with the count of ones in that particular row. If this is greater than our count of one, if this is greater than our count of one, then our count of one will be count of ones in that particular row, and we are updating our row as a row here. After that, we are returning the row number from here. Now let's make this binary search function. So public static int binary search, and it will contain the matrix, 2D matrix, and the row number. Okay, row number. Okay, now we are applying the binary search for we are calculating the count of ones by using binary search. Now for that, we need to initializing the two pointers, that is low pointer at 0 and the high pointer at matrix of 0 dot length, not the size function here, length function. Okay, length function. Now length. Okay, now matrix of 0 dot length minus 1, and we are initializing our first index of 1, matrix of 0 dot length. Okay, that will gives us the column value, columns value. Okay, columns length. Now we are running our while loop, that is it will, if low is less than equals to high, and the first work that we need to do here, calculate the mid by using low plus high divide by low plus high divide by 2, and we are checking that is matrix of row of mid contains 1 or 0. In the else part it contains 0. Okay, now we are checking that is matrix of row of mid. For example, we are passing the zeroth row and this matrix. Our low point is here and high point as this point, and this is the midpoint. Is our row of mid is our matrix of 0 of 2 contains 1 or not, 1 or 0. Is our matrix of 0 of 0 comma 2 contains 1 or 0. So it is contains 0. So basically it is in sorted order. Then we need to update our low as a mid plus 1, low as a mid plus 1, and again we are finding the our midpoint. Now our midpoint is at this point. We are checking again matrix of 0 comma 3, is this contain 1. If it is contain 1, then we are initialize updating our value as 3. Okay, updating our value as 3. Now let's write the code for it. Our matrix of row comma mid contains 0, so we are initializing our low as a mid plus 1, and after if we have that 1 point, then we are initializing that first index of 1 as a mid and updating our high as a mid minus 1. So this is the binary search. Now we need to calculate the count as well, count of 1. Okay, so the count of 1 is matrix of 0 dot length minus first index of 1 and return this count. Okay, return this count of 1. Okay, so this is the code. So let's try to run for the sample test case. So it is successfully run for the one test case. Let's try to submit it. So it is submitted. It is run for the all test case. So let's try to run over this code. So give me seconds. Okay, let's take a snap of this. This is our full code. Okay, this is our full code. Okay. Okay, now this is the main function. Main function means we are calling the find row from the main function, and from this function we are calling the binary search. So now first row is 0. At this point row is 0, row is 0. Okay, now we are at low point at this point, and row is 0 point. Okay, high is at this point. Now at this point we are initializing our f first index of 1 as a 5, and we are checking is low is less than equals to high, is 0 is less than equals to 4. Yes, it is true. Then we are calculating our mid, and our mid is present at this point. Now we are checking is matrix of row comma mid, is matrix of 0 comma 2 contains 1. It is 0. It is not contains 1. So we are going to the else part, and we are updating our low as a mid plus 1. 2 plus 1, that is 2 3. So our low point at this point. Again we are checking that is our 3 is less than equals to 4. Yes, it is. So then again we are calculating our midpoint at this point, and we are checking that again is our matrix of 3 is a 0 of 3 contains 1. Yes, it contains 1. Then we are updating our first index of 1, that is mid, our midpoint at this point, and we are updating our high point as a mid minus 1. That means our high point as 3 minus 1 2. Okay, now we are checking that is our 2, our high point at this point and low point at this point, is our 2, is our 3 is less than equals to 2, is our 3 is less than equals to 2. No, it is not true. So we are out of this loop, and we are calculating the count of 1 as a 5 minus first index of 1, that means 3, and it is 2. So it returns the value of 2 from here to here, and we have a faith that for the binary search it will return the count of 1 in that particular row, and it is returning that count of row in that 0th row. And now we are checking our first count of 1 is 0. We are checking count of ones in that row. This is 2 is greater than 0. Is this true? Yes, it is true, and we are updating our count of 1 as a 2. and row number, that is first 0, and we are also giving it 0. Now our for loop is running row plus plus. Now let's try with for the 2, row plus plus for the 2 times. Okay, now our row number is 2. We are passing the row. Okay, let me erase. Okay, now our row number is 2 and we are passing the row number is 2. Okay, now we are checking for this condition. Our for applying the binary search for this particular row, low at 0, low at this point, high at this point, first index of 1 at the fifth point. Now we are checking if 0th index is less than equals to 4 index. Yes, it is true. Then we are calculating our midpoint. So our midpoint at second index, and we are checking that is matrix of row of mid contains 1 is 2 comma 2 contains 1. Yes, it contains 1. So we are updating our this point as second index and updating our high point as a mid minus 1, updating our high point as a mid minus 1. Now at this point again we are checking is low is less than equals to high, is 0 is less than equals to high. Yes, it is true. Now we are calculating our mid, and our midpoint is at 0th index. Now at this point we are checking that is our 2 comma 0 contains 1, is our matrix of row comma mid contains 1, is our 2 comma 0 contains 1. No, it is not true. We are going to this part. We are updating our low as a mid plus 1, sorry, low as a mid plus 1. Now we are checking is low is less than equals to high, is 1 is less than equals to 1. Yes, it is true. Then again we are finding our mid and our midpoint at this point. Now we are checking is matrix of 2 comma 1 contains 1, is our matrix of 2 comma 1 contains 1. Yes, it contains 1. Then we are updating our first index of I as a 1 mid and updating our high point as a mid minus 1. That is, we are at this point now. Now we are checking that is 1 is less than equals to 0. Is 1 is less than equals to 0? No, it is not. So we are out of this loop, and we are calculating the value of count of ones in this particular. Now 5 minus where 5 minus 1, 5 minus 1, it will give us a 4, and this 4 is written from this position to this, and we have a faith in the binary search that it will return us the count of ones in that particular row, and it is the return that. Now for the for in that in the column of 1 we have the 2, and our column of ones in the particular row, that is 4. So 4 is greater than 2. This condition is true. Then we are updating the column of 1 as a 4 and updating our row number as a this row number. That means 2, and we are returning 2 from here, and this is our final answer. So I hope you understand the question and the solution and the dry run as well. So I hope thank you for the watching.